Alright, so page 3. So remember, the first question is to open up or down. I notice right away that number in the front is negative, so that's going to go down. Axis of symmetry. Well, this one's a little easier when it's in vertex form. So first I'm just going to say, what's the vertex? Okay, so it's going to be negative 2, because remember, x is a liar. Okay, then plus 12. Okay, so that means the axis of symmetry is x equals that same x value, negative 2. Okay, next question is it a min or max? Well, it's a graph that goes down, so it has to be a max. And remember, that point right there is our vertex, and the max is determined by the y value. So y, or actually let's put not y, but let's put the max is equal to 12. Okay, now the x-intercepts. All right, so in order to solve for this, to find the x-intercepts, we want to set this equal to 0, because remember, the y value at the x-intercept is equal to 0, so we're going to set it to 0. Negative 3 plus or minus 2, x plus 2 squared plus 12. Okay, first thing we want to do is subtract the 12 on both sides. Negative 12 equals negative 3 times x plus 2 squared. Now don't assume right away it's imaginary root, because you still got to follow through in the last step here before we square root. Just because that's negative. If you notice, we have to get rid of this negative 3, so we're dividing negative 3, and what happens to that? Now it becomes positive again. So there's still hope. Alright, so then that becomes 4, and I like that because I know when I square root 4, I'm going to get a nice whole number. Okay, so square root both sides. It's going to be plus or minus 2, don't forget the plus or minus. Okay, equals x plus 2, and I'm going to move this to the other side. It's plus positive here, so that becomes negative 2 plus or minus 2, or x equals. Okay, and go ahead and work that out. So first we have negative 2 plus 2 is 0, and then we have negative 2 minus 2 is negative 4. Okay, so our x-intercepts are x equals 0 and x equals negative 4. Okay, now the y-intercept, okay, we have to do something similar to this, except remember the y-intercept, the x is 0. So now we plug in 0 for x. So now y is equal to negative 3, 0 plus 2, and then plus 12. Okay, so now we have 0 plus 2 is 2, 2 squared is 4. Okay, so then we have negative 12 plus 12. Okay, well that's going to be 0. So the y-intercept is 0, or y equals 0. Okay, now the domain. Again, like I said before, domain for all parabolas, as long as it's not inverted. Okay, we haven't really got to inverted equations. We'll get to that later in the year. Okay, it will be all real numbers, or it's going to be infinity both ways. Okay, now the range, again, that's determined by the y value. Okay, so this, remember, we always start from the bottom going up. So we're not going to put 12 first, because first going down, it's going to negative infinity, and then it goes up and stops at 12. Okay, so a graph that goes down, remember, you're going to start with infinity first. If it's going up, that's when you're going to start with the number first. Okay, now decreasing interval. Okay, actually, you know, we'll do this. We'll just start on the left side. Okay, on the left side, this is increase. So we'll start with the increase. And remember, this is x. Okay, so it starts at negative infinity. So the decrease starts on the negative infinity side for x. So negative infinity. And then as you get closer to negative 2, that's when it stops. So we get negative 2 here, parenthesis, and then a bracket, and then decrease on the other side. So decrease starts at negative 2, okay, and then goes off to infinity. Okay, the end behavior, again, is just like the other page. As x approaches negative infinity, which is to the left, it's going down. So now f of x is approaching negative infinity. As x approaches positive infinity to the right, it's doing the same thing, going to positive infinity. Okay, so now let's graph this. Okay, so at negative 2, 1, 2, 1, 2, other way. We're going to go up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then we go up to here. Okay, now remember what I told you before, that's 3 in the front, so it's going down, so we'll go 1 to the right, and then down 3, and then we can do the same thing going the other way, down 3. Okay, now remember that pattern is 1, 4, 9, 16, so the next number is going to be triple that. So 1 to the right, then down, then from here will be down 12, so that will go all the way back down to the line here. And it'll be to the left as well. And we actually already have the x-intercepts, so I can just go ahead and graph those. And we actually also have the y-intercept too, which is the same. And it's a graph that goes down. So we actually already have a few points to work with. Okay, so now write the function in vertex form and identify its vertex. Okay, so what we want to do here, okay, I'm actually going to stop and I'll just demonstrate this in class. So now we need to write the function in vertex form and identify its vertex. Okay, so what we want to do in order to turn this into vertex form, we're going to take the first two terms and separate them from the last term. So I'm just going to kind of spread it out. Okay, so first I'm going to put parentheses here and plus 6 here. I want to treat this like I'm factoring for the greatest common factor. So I'm going to take out a 2. So now this becomes 2 times x squared minus 4x. Now what I'm going to do is leave space in here because I'm going to use the complete the square method in order to complete this. Alright, so then I'm going to put plus 6 here. So first on the inside we want to complete the square. So half of negative 4 is negative 2. The negative 2 squared is plus 4. Okay, so here's the deal. In order to balance this equation, okay, I can't just add 4 to this side and have it still be balanced. So what I have to do is add another number out here. Okay? In order for this to be balanced and to equal the same, it had to be negative whatever went in there. So it's not, but the thing is it's not negative 4. Okay? Because when I multiply this out and I do 2 times 4, that's actually going to be 8. So I want to put minus 8 here. Okay? So now what I want to do is factor this, factor the parentheses. So now I have f of x equals 2 times x minus 2 squared. Okay? And then I'm going to add the like terms out here, so that will be minus 2. And there's the vertex form. But the second part of the question is, what is the vertex? The vertex is positive 2 and negative 2. So again, take the first two terms, GCF, okay, and then with those two terms on the inside, complete the square. But again, you're going to have to do the opposite. You're going to have that same number that's inside, multiply times whatever's here, and put the opposite number here in order to balance it. Okay, now again, we're skipping this one, skipping 14, skipping 15, so don't do that. Okay, now solve this equation in two different ways. So you can pick whatever way you'd like. So if I always try factoring first, just to see if it'll work. Negative 3 here, negative 6 here. Right away, I know this isn't going to work, because there's no number that'll add up to 6, but also multiply to 3. Okay, so now I'm thinking maybe complete the square. So first let's move the 3 over to this side. So we have x squared minus 6x is equal to positive 3. And remember, don't forget, when I move that, that's got to change the sign. Now let's complete the square. So half of negative 6, negative 3. Negative 3 squared plus 9, both sides. And so here's the difference between this problem and this problem. Here, I'm adding that 4 and this 8 to the same side. So that's why I need the opposite sign. Down here, I'm adding them to the other side. So as long as they're on different sides of the equal sign, then you're going to add the same, you wouldn't add the opposites, you're going to add the same number. Okay. So now, factor this. Okay, so this would be x minus 3 squared, and then 12 over here. Okay, square root both sides, x minus 3 equals plus and minus square root of 12. Okay, then I'm going to move the 3 back over to this side. That becomes positive 3 plus or minus square root of 12. And now I want to find the decimal answer to the nearest hundredth. Okay, so we're going to do 3 plus square root of 12. And that'll be 6.46, so around that. 6.46. But again, we have to do the other solution, so go back up, change that to minus, and then we get negative 0.46. Okay, but then it asks you to do it in two different ways. Okay, so the next way that I'm thinking is let's do the quadratic formula. Okay, so our A is going to be 1, our B is going to be minus 6, our C is going to be minus 3. Okay, so then we're going to plug in, well first don't forget it again, don't forget that negative out there where the negative B is. So negative times negative 6 plus and minus square root negative 4, B squared. Okay, so negative 6 squared is 36 minus 4 times A 1 times C minus 3. Okay, over 2 times 1. Okay, now this becomes, and again, this is all equal to x. So this becomes positive 6. Okay, I'm going to work this part out. So this will be negative 4 times 1 times negative 3 is positive 12. So that's 36 plus 12. Okay, so that becomes plus or minus the square root of, let's see, 48 over 2. Okay, so now I'm just going to go ahead and convert this to decimal. So first what I'll do is 6 plus square root of 48. But don't forget, divide by 2. Okay, so there's my first solution. And again, should these be different? No, I should get the same solution. If I'm doing the same problem, just two different ways. Okay. Now I could just write this out and put that same solution, but let's go ahead and work it out just to make sure that I was right the first time. So minus square root of 48 this time, and then divide by 2, same answer. And don't forget the negative. Okay, that's it.